Hi, Doc Revis here with Watch Me Work It, gas law math, doing the calculations, and a few other things that go along with it. So watch me work it. Here's an example of a problem that was presented. A flexible vessel, these are gas law problems. A flexible vessel contains 27.8 liters of gas, is collected at minus 115 C, and then allowed to expand to 49.7 liters. What must the new temperature in CB to maintain the same pressure? This is an example of a student work problems, and I want to use it to show you how to make a few improvements here, particularly in watching for the math. So we know what the gas law is because we notice this is a V and this is a T as well. And we have a second V and we have a T in question. So that's T2 in question. Second T, and this is T1, so this is V1 here. So we automatically here 273 to get the final temperature that we're going to use for this particular problem, and that's going to be 158 K because it has to be in K. But in any regard, take a look. The student here set up the problem properly with the V1 over T1, V2 over T2, Charles's law. And that's set up perfectly. I advise, however, that you change these to capital letters so you don't confuse it with time later. But that's set up perfectly. Well done. Here, the student did a really good job in making the conversion. Well done. The setup here, put in the values, set up perfectly. Now, the next part is to do the calculations. And this is where sometimes students will have problems, but here's how you do it. To solve any of the problems that look like this, what you do is you multiply the diagonals, these two numbers, multiply them and divide by the leftover. Get it? That's what I did here. So this number is on the diagonal, this number is on the diagonal, so I multiply them. And then I divide by the leftover. It's that straightforward. Regardless of where the T is located, if T is on the top, is on the left, wherever it's located, multiply, cross multiply the diagonals and divide by the leftovers. Okay? So in other words, I took 158, which is on the 158, sorry about the look there, times 49.7. That's the diagonal, and I divide by the leftover. I call it leftover just for convenience, 8, and that equals T2. The other thing you want to note here, this equal sign should have a T2 in front of it, okay, properly written. Okay, and so it subtract out the minus 273. Now this is the wrong solution because of the math, but the setup is perfect. You'd hate to lose points simply because you don't finish your math off. Okay, so here we show you how it looks in the calculator. So in the calculator, you punch in 158 times 158 times 49.7, and then divide by 27.8. We get this number, 282, and some decimals, minus 273, and you'll get the proper answer. So the answer should be approximately 347, and that should be in degrees C for the solution. Okay, so again, the student had it set up really well set up, but the math got in the way of getting the proper solution. Okay, let me do that on another problem. Hopefully we'll do a little cleaner for you. Here's another problem. The gas is in a spray can, have a temperature, that's a T, temperature here, and a pressure, so that's a T1. So we're going to add plus 273 here automatically. So we get converted to K. Gas laws, you need K. So we have pressure. It doesn't matter as long as the unit matches. The pressure is P1. It matches this P2 pressure. And look like we're looking for T2. Again, I highly recommend these not be lowercase, capital T's by convention. Okay. Now, the other thing here, another mistake is this is a times. This should be an equal. Okay. This should not be a times. This should be an equal sign here. And this should not be an equal here. It should be T2 equals that. Okay, but that notwithstanding, student knew exactly what they were doing. They changed the K. Well done. They set it up properly. Well done. The times, okay, we can overlook that for now. But set up well here, set up well here. But the math, So what you do is take the diagonals. This is the diagonals. Multiply them. So that diagonal times that is what we did right here. And then we divide by the leftover, which is across from the T2. The leftover is always across from what you're looking for, by the way, always. The thing you divide by will always be across from crisscross from what you're looking for. So we punch that through, we get this number on the calculator, and then we subtract the minus 273, and we don't get this solution because, again, math got in the way here. So math got in the way, but the answer should be 206 here for, look, it should have been, how many sig figs to start with? Looks like 2 or 3 actually default to the pound, so 3 sig figs, and that would be in degree C. So that's how you work it. The key is to watch for the math. So to recap, when solving problems where you have ratios like those shown here with one variable that you're looking for, crisscross multiply the diagonal values and then divide by whatever is across from the variable you're looking for. In this case is a T2. Okay, so that's it.